Okay, what we're going to do here is we're going to try some more advanced factoring problems. So you've seen at this point techniques such as factor by grouping, factoring trinomials, difference of squares, difference of cubes, and sum of cubes. What we're going to do here is start putting some of these techniques together. A big mistake that I often see on a test or whatever is factoring and getting the right first step, but not realizing that there are further steps to be done, that this has to be factored completely. So after we do our initial factoring, we have to make sure that we are indeed done. So here's an example of what I mean by that. We have factor completely, x cubed minus 3x squared minus 16x plus 48. Okay, so let's see how we would start this. I have four terms here, cubed, squared, x, and a constant term. So I'm going to want to factor this by grouping. Certainly, I want to take maybe these two and group them, and maybe these two and group them. Because obviously I can't take a single greatest common factor out of all four of them. It doesn't exist. So I also noticed that there's a 3-to-1, or more specifically, a negative 3-to-1 ratio here, and a negative 3-to-1 ratio here. So these are good groups to use. Not the only groups, but they'll work for us. Okay, so let's start with this term, the left two terms over here. I can factor out an x squared, and on top of that, I can factor out that's just x squared. Okay, so I got x squared factored out, and this is going to wind up as an x minus 3. All right, now I take this group over here, 16x, or negative 16x plus 48. What can I factor out here? Well, a negative 16 x minus 3. All right, now I see that I have common factor here and common factor here, so I can now take my common factor of x minus 3, and my other factor is going to be x squared minus 16. Of course, that's not done. I mean, this x squared minus 16, you have to realize that this x squared minus 16 can be factored further. All right, so the x minus 3, we can't do anything more with that. But the x squared minus 16, this could be what? Well, we have a difference of squares. So x plus 4, x minus 4. So that is our final fully factored answer. Let's see a few more of them. Let's go through some of these more advanced factoring problems. Okay, here's another one that will confuse people sometimes. X to the fourth plus 3x squared minus 4. So we have an x to the fourth term here, and we only have 3 terms, so it doesn't look like we're going to use factor by grouping with this. This is a trinomial, right? We have 3 terms. Now, don't get scared off by the fact that we have an x to the fourth. Let's just think about this. If this were, suppose, I'm going to go all the way up to the right here. Suppose this were x squared plus 3x minus 4. Well, what would we do here? Well, we would factor this. We would find two numbers multiplying to negative 4 and adding up 3. right? So 4 and -1 would work. And we'd factor appropriately. We'd have an x plus 4 and an x minus 1. So we could do the same thing here. Only difference is this is going to result in x squared plus 4 times x minus 1. And let's check this, right? We have x squared. So we have x squared times x squared, that's x to the fourth. 4x squared minus x squared, that gives us 3x squared. 4 times -1 gives us 4. This is fine, but again, remember we have another set of factoring still to do. That x squared minus 1. So the x squared plus 4, well, we're done with that. X squared plus 4, that's a sum of squares. A sum of squares is not factorable. The difference of squares is, and so we're going to finish up by taking x plus 1, x minus 1. It said minus 1. Something's up with this pen. Okay. All right, let's take a look at a couple more here. Okay, so this is another one that kind of might scare people off because we see a y in here. Oh, there's a 6y squared and minus 5xy. Don't be intimidated by the fact that you see a second variable here. Just like we saw in the last example with the x to the fourth, again, just focus on how you would do this factoring if you had, let's say, instead we had x squared minus 5x plus 6. Suppose you had x squared minus 5x plus 6. What would you do? Well, I'd find two numbers multiplying to 6 and adding to -5, so I'd make it -3 and -2. And that's the exact thing that I'm going to do here. The only difference here is that, okay, well, let's take the x and the x. That doesn't change, all right? But, okay, instead of having a -2 and a -3, it's going to be in -2y and a -3y. Everything else is exactly the same. -2xy minus 3xy gives us -5xy, and -2y times -3y gives us positive 6y squared. That is it. Don't let this scare you off, this y at the end. It doesn't change the factoring at all. I mean, it changes the final answer that you have a y in it, but other than that, the process of factoring trinomials is exactly the same, whether those y variables are there or not. Okay, one more I have here. Another factoring, again, we have another factor by grouping here because we have 4 terms. So again, I have one group here, I erased that 3, and one group here. All right, so let's start with the first 2 terms. Let's factor out an x cubed, we could do that. That makes this an x minus 2. Okay. And then what about that second term? Well, that's already x minus 2. There's not much we could do there. So I'll just, well, I'll put in a 1 there. It likes to erase straight lines as soon as I draw them. Okay. Okay, so let's complete the factor by grouping. Now we have x minus 2 as a factor. And we have x cubed plus 1. But again, factor completely. I didn't state completely up here, but we still got to make sure, no matter what, we got to factor this completely. What more can we do here? Well, let's remember the formula for factoring a sum of cubes. All right. So we have x squared, x cubed rather, plus a cubed, that's an a. Let's try this again. X cubed plus a cubed equals x plus a times x squared x squared minus ax plus a, if I can fit this in, a squared. Okay, so let's follow that pattern over here. This is going to become x minus 2 times x plus 1 times x squared minus x times 1. That's going to be x squared minus x plus 1. Okay, and that is now factored completely.